Okay, you just started. Great. Awesome. Great. Hey, everybody. Welcome to Data Engineers Lunch number 5. Coming to almost the end of the year. And if you're not speaking, please mute yourself. Or Akwi, if you can mute everybody else for me, please. Thank you. Hey, everybody. Welcome to Data Engineers Lunch number 5. We're at almost at the end of the year. My calendar says we're at week number 51, but I think there's another half week left after next week. Today's topic is, it's a discussion about what is a data lake, and this is a common question we get. It's not something that even I knew early. Getting into data engineering. Data lakes were stuff that big companies used to use, and everything else was just done with databases. But the term has really evolved over the last, I would say, 10 years that I've seen it around. We can quickly do a trends. I love Google Trends. I bet they have a massive data lake. But if you look at data lake as a search term, it started probably in 2006. No, it's been around. Wow, it's been around even longer than I thought. But it started to take root really in the last, say, 5 or 6 years, because it was no longer just very large companies using very big, basically a big drive, right? So let's see what HDFS comes up as. Yeah, my guess was around 10 years ago, HDFS starts to become a very useful technology for data lakes. And then S3 is also a very common data lake. And it started getting used around 2010. So wow, look at that. It was the most popular in 2012. I don't understand this. Maybe they're talking about the Audi S3. Let's see, Amazon S3 as a technology. Nope, maybe, no, that's weird. Looking at that as an internet protocol. Anyways, I can go in deep into Google Trends and not come out. But anyways, we're gonna talk about what is a data lake. Welcome, thanks Akwi for helping organize this. Akwi is responsible for getting this recorded and then published on YouTube, as well as making sure that there's blog posts that go out with all the comments about what we speak and chat about. Always looking for help, always looking for speakers. If you have a specific topic you want to talk about. Data Community DC is a large group of data practitioners in the DC area. We are very inclusive and welcome people from all different backgrounds to come and speak and volunteer. As you can see, we are one of many different groups. We cover all things related to data, moving data, processing data, for the purpose of getting it ready for other people, either via API or for people to use BI tools on top of, or data scientists to use machine learning on top of. So without data engineering, those folks wouldn't be able to do what they need. And actually, a lot of data scientists and data analysts have to do data engineering to do their job. Let's see if there's anybody new. I think most people have been here before. Yep. Group rules, just if you have a question, ask it. If you have a comment, just put it in the chat, or just chime in, as long as you don't have too much background noise. Our company Anant is a sponsor. We love dealing with fast data. DataStax is a sponsor and a partner. So is George Washington University around the corner from here, or at least where I live, who has in the past given us amazing venues. Hope they will continue to do that. We have some local sponsors, as well as some institutional sponsors for all of Data Community DC. All right, any announcements for any meetups, conferences, hackathons, anybody hiring? Will, anything coming up in your neck of the woods?
Yeah, thank you. The Bethesda Data Science Meetup has an event on Wednesday that's going to be on censored data collection with microcontrollers.
Cool.
And that should be fun. I believe it's 5 to 6:30 p.m.
Awesome.
And I need to finish my presentation for that.
I think I can make that. It's on Wednesday.
I believe that's the case. Yep, Wednesday the 16th.
I have to log in, but that's cool. Thank you. Thank you.
Mm-hmm.
Appreciate that. Very cool. Anything else? So Aki's a little under the weather. I'm going to go ahead and speak for him. There are a few Spark related talks which are related to data engineering if you use Spark for data engineering. But there's this talk tomorrow about data lakes actually. And Obi can maybe comment a little bit about this when we get started. There's also another one on just distributed ML libraries in Spark. And then the following week, we have Databricks, which is basically a hosted version of Spark, and Astra, which is a hosted version of Cassandra. And then also using notebooks with that. Wow, getting close to that. I don't know why there's some. Is that you, Arpan? You're like, really want to meet our quota for getting the presentations out there. Like by this point, nobody's working. Awesome. Awesome. Well, thanks everybody for coming. Let's go ahead and get started with the topic for today, which is data lakes. You know, we're following this journey for our data engineering roadmap, which, you know, we talked about programming. We talked a little bit about scripting and automation. We also actually talked a little bit about scheduling. We'll give a presentation on Airflow. And then just continuing down the line, one of the things we're gonna cover today is data lakes, because essentially I would say one of the first raw tasks a data engineer will get in a data science world is here's a bunch of raw data. We need to do stuff with it. And most raw data ends up in a data lake first, or it has to be brought from elsewhere, put into a data lake so that your systems have access to it to do further processing. So, you know, let's go ahead and get into this. By the way, a lot of people here have experience with data lakes, so please chime in. So what is a data lake? Well, data lake is basically, it's all types of data, but really the point of a data lake is that you keep dumping stuff into it. And a data lake should not run out of room. You know, it's everything you can imagine forever in one place. How you organize it depends on organization. Some people will organize data by date. Some people will organize data by department and then by date. Some people will just put stuff in there and not organize it at all, which is something that you eventually have to do anyways. But data storage, really, that's what a data lake is. It's this place to just dump raw data. And normally that is files or as object. What we mean by object is that systems like distributed systems like S3 or MinIO, they're called object stores because you take any kind of computing platform and you can say store this thing in this location, and under the hood it's storing an object for you. Now obviously it's saving it somewhere on a disk. Now some people use that object store as a file system. So for example, S3, it's an object store, basically one of the biggest databases in the world, but you can use it to put files into it. So when you put a file on S3, your key is the location of the file and your object is basically the file itself. So now with that, what can we put into a data lake? Anything. So some people will take structured data from databases, export it as CSV or tab delimited, tab delimited TSV, I guess. Yeah, sure. Tab separated, or even as JSON. So just from relational databases, they'll take data, right, and they'll just dump it, and it'll have all the foreign keys and primary keys in there, and you do what you want to do with it. Sometimes this data comes in as full-on exports, and sometimes it's deltas, meaning incremental updates, right? Why would people do that? Well, some relational databases, actually most of them, right, they're not distributed. There's some new ones out there. So you can't just keep adding stuff to a relational database. You want to archive it somewhere. So if you want to be able to access that information later in the same type of general way, if you dump it to a data lake, and we'll talk about how to query it later, you can get a similar type of queryable data set back in a data lake, depending on which query engine you use. This is one of the ways, the first way somebody starts using a data lake is saying, let's just start dumping our databases to a data lake and start using analytics to connect and do analysis on all of our databases in one place. So if you had like 50 database servers, you could just dump everything into one data lake, and you could query all of that data in a data lake, given your query engine or your processing engine. Semi-structured, what I mean by semi-structured is that it could have some structure like fields, but it could also just have text. So logs are generally semi-structured, right? There's a date, there's a component, and then there's blah, the message. XML is structured, but you can also have text content inside XML, as with JSON, right? And when we say semi-structured, how is this different from structured data from relational database? It really, there's no difference. Actually, there's no difference. It's just the format. It's just that when people move data, they're really just looking at structured, meaning literally this is a database, semi-structured, which is commonly text and fields, and then purely unstructured data, which is like emails, documents, text files, you name it. And then you can also, because of the magic of machine learning, you could be analyzing video and audio. You can assume that binary data can also be a part of a data lake. How do people deal with data lakes? They usually make a decision on whether it's on-premise or cloud because of security reasons. And let's see, this is in here. Yeah, I have some implementations that I'm going to get into, but generally, when we talk about on-premise, people are using things like HDFS. That's kind of the most common one I've seen. And then recently, folks are starting to use min.io. If you're not familiar with HDFS, HDFS is the Hadoop distributed file system. It's basically implemented as a implementation of Google's distributed file system paper, and it powers many big data platforms. So HDFS. HDFS not only is a file system, HDFS also is commonly seen as a protocol. So S3 can be accessed using the HDFS clients. DSCFS, which DataStax has, it can be accessed using the HDFS compliant protocol. So while HDFS is a protocol, right? So you can use it with S3. You can use it obviously with HDFS. You can also use it with min.io. And so there's lots of, and by the way, any cloud provider will give you HDFS access to their distributed system. If they don't, then they're not really providing a data lake. And then I just mentioned min.io, but min.io is basically a technology to allow people to do their own object stores in a cloud native, meaning containerized world. And it's accessible using the S3 API, right? And you can look into this. This is fairly new technologies out there that mimic this. And the last one, there's another one called Ceph. So Ceph is another kind of storage engine, object storage, block storage file system, and you can do it yourself, right? I think, are they owned by Red Hat now? No, they're not owned by Red Hat yet. But they're Ceph, and thinking there's another one, but it'll come to me. So these are kind of the on-premise ones, and then the cloud, any cloud. So Google, Azure, Amazon, obviously S3. these are all, data lakes, or can be data lakes. Why do you need a data lake? I just put one answer: can finally do cool stuff with data science. Meaning, folks, I remember when machine learning and data science it's still a buzz, but everybody wanted to learn this stuff, or companies wanted to use big data, right? And they didn't know that the first step to doing anything with the big data is you got to have a data lake first. You have to bring it all together. You have to get all your shit together in one place first, so that you can do things with data science. So stepping stone is like, you got to have a data lake, right? Then you got to do some data engineering / wrangling to clean the data. And you save it back to the data lake, right? That's kind of the easiest way. Here's a comment. Yeah, good questions, Will. Yeah. Actually, you want to comment on number 2, Will?
Sure. Let me go ahead and get my camera on. Yeah. So I had an experience earlier this year where, as an analyst, I had done a sort of data audit to see what people in the company needed, and this was at a 20-person company. And one of my sort of longer-term recommendations was to expand our use of Google BigQuery and really turn it into like a data lake, data warehouse. And one of the executives had a huge negative response to this, because in their mind, a data lake, data warehousing project is a massive enterprise undertaking that's going to cost huge amounts of money. And so I think a lot of this terminology, depending on who is interacting with it, can mean radically different things, because like you said, the cost and the popularity of these has increased a lot over the last several years as the technology and tooling has gotten better. And so it's a lot cheaper and simpler to spin up something approximating a data lake than it ever has been.
Absolutely, totally agree with you. Yeah, and actually, I have added a few things like BigQuery, and actually Snowflake is another one down there. But yeah, making a data lake today is as easy as making a bucket in S3 and dumping files to it. It wasn't that easy. Before S3, before Amazon S3, doing Hadoop was a job. Like installing Hadoop was a job, maintaining Hadoop was a job, like maybe 3 people's jobs to like run a Hadoop cluster, because there are so many different components to it. And now people, as they start to use other things other than MapReduce, they still use HDFS. Either they're managing it themselves, or they're moving off to cloud to have their version of HDFS. In fact, one of the clients I'm working with right now, they have HDFS. They also have DSCFS, and it's a lot of data, and they have to keep these machines up and running all the time just to have this data available. And so as they move to the cloud, I'm recommending using things like Azure blob storage, or they have something called Azure Data Lake Generation 2, which you just dump data into, and then you have the ability to access it using Spark. You have that ability to then access it using Azure HD Insight. Or if they were to go to Amazon, I would say, put everything on S3. And it was funny when I explained to them the concept of, oh, we just need to allocate this much space. They're like, well, we're gonna have way more data. I'm like, that's fine. We'll just pay for it as it increases, because we don't have to allocate out 100 terabytes right now. We can just allocate 5 terabytes and let's just dump data into it. And so that's the other thing about, you're right about the terminology. People don't think about S3 as a data lake. They don't think about Azure blob storage as a data lake. And I'm glad at least Azure is calling it Azure Data Lake version, Generation 2. And people are like, oh yeah, let's do that. It's nothing different. It's the same thing.
Hey, guys, so to add to, Rahul, yours and Will's point, the first question there about Swamp, right? So the trend, let me turn on my video here. So the trend I have seen most recently is, well, at least for 2 years now, that you can use data lake S3, but you just can't put garbage in it. So what trend I'm seeing is like you use some sort of streaming service like Kafka or some stream. So that's requirement number one. Another requirement is like you gotta define like a catalog, like follow a catalog system. What this data is, what are all the columns, right? Is it PCI data? Is it uh, what sort of security does what sort of category this data falls into, so that it can be administered accordingly. So that actually has reduced, in my observation, the swamp nature of the data lake.
Yeah.
Like, and I mean, any data you're collecting, no matter how raw it is, right? It will have some meaning, like it will have some sort of catalog nature to it. It will have some sort of security feature associated with, is it just garbage, or is it somebody's address, or name, or so what sort of category. So that, I mean, in short, that's the trend I've seen to kind of reduce the swamp nature of the I like the word, Will.
Yeah, that is very, very well spoken. And I just want to really emphasize one of the points that you said, which is, cataloging.
Mhm.
Metadata about data, I think, is the most important thing here.
Yeah,
Because one
that's
thing
right.
that I'm sure most of us have run into, even when working with nice clean data sets, is you get a CSV or a database, and the field names don't necessarily indicate what the data actually means or what it is in a business context.
Right.
So, I think actually the really hard things about data lake are all of the business and social decisions in terms of the processes around data governance and who's responsible for that metadata and that cataloging, make sure it stays up to date. Because if people can't find the data that they want in a data lake, that
Yep.
defeats the purpose.
Yeah.
And then data cleaning, because if the data is impossible to work with, then you still effectively need to get data engineers to come in and clean it up again. And so you really have a challenging trade-off between difficulty on write, because if people can just dump everything in without having to do a lot of cleaning and metadata, they're more likely to do that.
Mhm.
But then the value is lower, and you have to do all of that cleaning and analysis when you're reading the data. So I think one thing that can be one architecture that can be effective is to effectively have two data lakes. One is the sort of ingestion point, and then you clean it and process it into a sort of cleaned data lake, not quite as polished as the data warehouse, but a lot closer.
Yeah. So associate, I mean, very related to that topic. Well, I've seen that the whatever data they were pouring into the data lake had two sorts of catalog, like one for business and other technical, and each of them have like a dataset ID, right? So business has their own dataset ID for about the same data and whatever the stuff they do. So things like aspects, right? If they're pouring in data from some source to this data lake, is the source 102 million records and the destination also 102 million records. So to do those kind of tallies, business has their own dataset ID, versus technical, where we are concerned about the type of the column and things like that. So there's a separate dataset ID for that, as I have seen in the past 2 years, and that definitely has sort of controlled turning the data lake into a swamp. But
Yeah.
very good point. Yeah, I agree. Thank you, guys.
Yeah, and actually, what I was showing something where you guys were speaking. There's actually a project, an open source Apache project. If you wait long enough, there will be an Apache project for it. It's called Apache Atlas, and it actually provides an open source way of managing governance on top of Hadoop, basically. Schema management, metadata management. I don't know if it actually does security. Hey, maybe it does. Yeah, I think it does. But this is something I just started looking into recently. But if you just take a look at the high level architecture, what is it doing? Well, there's potentially metadata from other places, and what's happening in the core here. this is the metadata store. This is not the actual data store. This is the metadata store, right? So as data gets put into HDFS, you still have to update this stuff. If you don't update this stuff, it's not going to matter, right? So even if you put really good garbage in, you want to catalog it. And one thing you mentioned, Will, was having different data lakes, and this is a common pattern. Databricks calls it bronze, silver, and gold, where their bronze is their raw ingestion. Silver is their filtered, clean, augmented data, and then gold is what they call business level aggregates, which is as close to your warehouse as you're going to get on a data lake. Because Databricks is not a database technology; it's Spark, but it has a couple of libraries that allow you to access information. Delta Lake, which I'll talk about in a second, and you see this thing over and over again, different ways that they show this picture. And you can do this on top of anything. You can do it on top of HDFS. You can do it on top of Azure. You can do it on top of S3. It doesn't really matter. Point is that you are segmenting your data into these kind of qualities. Other people that I've worked with have called it different things, like ingestion data store, enhanced data store, and I don't even know what they called it. Maybe they called it just data lake, clean data lake, or something like that. But Databricks calls it bronze, silver, gold, and more and more people that have worked with Databricks, they start to say, hey, what's your gold level data? Maybe that'll stick. So I was just putting here, separate, use Databricks, bronze, silver, gold terminology. I like it because it's easy to remember, and it sticks. It doesn't necessarily have to do with a domain, right? Anybody can use this terminology. So good question, good discussion. So how do we get data in and out? And this is not a comprehensive list at all. This is just high level. It's the same way you get data in and out of any other system, except that in the load, what you're doing is you're getting something from somewhere and you're loading it. This is the common data lake process. You load it first, and then you can do stuff with it later. If you don't load it in the data lake itself first, then what's the point of having a data lake, right? You got to have a landing zone, right? So first and foremost, you're ingesting it, you're landing it into an area, maybe a bronze level, data lake. Some folks will do a transformation before they load it. I think what you were saying, Nirmal, streaming it into Kafka, basically you're forcing the person to clean up and structure stuff so that when you put it into Kafka, it's already transformed to a certain spec, and then you can have another Kafka processor or Kafka connector and save that data to your data lake.
That's right. For like certain data that has to have a schema, because Kafka sort of allows you to have a schema for anything that you want to stream. But then there are other systems that you can definitely use where you don't need a schema.
Yep. Yeah, and that's what I meant here. You don't have to have a schema to put stuff, because Kafka has a way to do schema. It doesn't require it.
That's right.
You could use Kafka to like save videos too.
Yep.
It doesn't really matter. And then streaming versus batching. The biggest reason people have HDFS on premise is because HDFS can support petabytes of data, and there is a break-even point, and then there's a point at which on-premise HDFS is cheaper than the cloud, not for maintenance, but from a literal hardware perspective, where some people who have the means, the enterprises that have the means, they would just rather own the hardware and manage it, because the cost at some point, they have enough data where they have to have their own cloud. They have to have their own private cloud. And in that case, you are just probably adding terabytes of data on a daily basis, right? Extract, egress, same thing, but there's something new here these days. If it's a modern data lake, there's actually a way to do queries on top of it. So let's see, there's Snowflake that supports some of this. BigQuery, as Will was mentioning. There's Amazon Athena, I believe. Yep, Amazon Athena.
Yeah, Athena is quite good, though. If you're expecting it to work as comfortably as a relational database, you'll be sad when trying to get it to data type things correctly.
But you got to use, you can use Amazon Glue, right? Their data catalog to help you with that. So let's see what else we got here. We have Azure Data Analytics, which is, it looks awfully similar to Snowflake in terms of being able to like do queries off of files. And then I want to say Presto, if you have data in HDFS, certain structured data sets you could pull directly off of HDFS, and Presto keeps its own data catalog in Hive. So anything that's Hive compliant, Presto can give you access to. And then just general Spark SQL, right? Spark SQL or just Spark data frames. You can load a data frame from Parquet files or CSV files or whatever, and you can access it off of S3. You can access it off of HDFS. You don't have to have that stored anywhere, right? So loading it, you know, you've got some limitations. I wouldn't say there are limitations. It's just, you're not, well, maybe in Spark. I was going to say, like, you can basically say, you know, get this stuff from data frame from this other place, you know, and then save this data frame elsewhere. You can kind of do stuff like that with Spark. So I think you can do that. But on the query side, what we didn't have until recently were all of these options to basically query data directly. And the first thing that allowed people to do that was actually Hive. Hive was the first system that allowed you to do these structured queries on top of basically unstructured data or semi-structured data. Anything else some people have seen recently on the query engines? I think that covers most of it. Yeah, I don't know. Maybe there's another one out there today. Stuff changes all the time.
Presto has been most popular, yeah, for querying concurrently, you know, separate types of data. Presto has been most popular. I mean, in my world so far. But yeah, it's gotta be another evolving tool that you can use.
Yeah, so I mean, everything has its like, you know, pros and cons, right? So Snowflake is commercial. It can get expensive. It's pretty good otherwise. There's actually, you know what? Redshift they announced it last year as a brand new thing. I think it was called Redshift Data Lake or something like that.
Spectrum, you mean?
Spectrum, yeah, exactly. Redshift Spectrum, that's right. Forgot the name.
It's actually, the way I see a Spectrum is doing a cost saving for you. So instead of going for another humongous, you know, feature off of Redshift, you could just use a Spectrum. So kind of think of it like a Hive on top of some unstructured data or S3 where you can query. So for smaller pieces of data that you need to, you know, make your workflow go through, you would use a Spectrum, kind of like temporarily awesome feature which cost a lot, but just for a little bit. So that's where you use that Spectrum.
Yeah, and actually it's Amazon's attempt at Snowflake. So the way Snowflake works is you define these kind of data stores. It stores data on S3, or if you're using Snowflake on Azure, it stores it on Azure Blob Storage. So your storage is separate from your query. So you can have petabytes of data sitting in S3, and then you have a different system that does a query on top of that data. And depending on what you need to do, you can size up your what's called virtual warehouses out to what you need to do. So Spectrum is very similar to that. Its storage is separate, as you said, and the query is cost optimized for that.
Right.
Yeah, go ahead.
Yeah, that's all. I agree.
and I think Google BigQuery is similar, right, Will? They have a different storage, and then Query itself is its own engine.
Yeah, yeah. So the storage and this engine are separate, but there it's nice because it's entirely pay as you go, both for storage and for the queries.
Yep.
And the native query scaling is very powerful. So if you have some monstrous SQL query over some pretty large data, it'll just keep throwing more compute at that. And at least compare for like medium to like small to medium data sets, you know, tens of gigabytes, BigQuery is incredibly cheap compared to Redshift.
Yep. Yeah. Yeah. And as you can see, all of these options kind of, you know, they have their own storage engine, and they have their own query engine. This is called Azure Data Analytics. But you know what? It's not like you have to use these engines. I don't know what Snowflake's is called, Snowflake Core Language, but it's basically like SQL. Let's see. Jay has Metcat versus schema registry is a comment. So I'll come back to the schema registry in a second. So Obi, you said, think the cost scaling is also interesting. It sorts your data into categories based on how often you access it and the less you access it. Less you access it, the less you pay. Which one, Obi, are you talking about when you say that? Is that Amazon?
Well, I know that Amazon has at least 2 buckets with some analytics there in between. And I'm looking at Google Cloud Platform's Google storage, and it looks like they have a couple, like 3 or 4, that are all at different cost levels depending on how often you need to access them. It's like, I think 30 days, 90 days, a year.
Got it.
And if you access it more often than that, then you charge more.
Gotcha. Yeah, I think, well, I don't know which one automatically does it, but I'm pretty sure at least on Azure, you can choose hot or cool, or you can switch it. On S3, it may be doing it automatically.
I think S3 has some level of analytics that can do that for you automatically.
Okay, cool. Very cool. So Jay mentioned something about Metcat versus schema registry. You can explore blah, 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 blah. I guess Metcat is basically kind of discovering your schema. I wonder if it discovers it or if you have to update it. Process it. Okay, interesting. So it gives you access to not only Cassandra, but S3, Redshift, Teradata, RDS. Interesting. Metadata discovery. Cool. I'm going to save this because it's Teradata. No, I don't have Teradata tag. And what else does it support? RDS. Awesome. Very cool. Thanks for the suggestion. Yeah, so it looks like Metcat finds your information for you. And there are, by the way, much more expensive tools that can find out the stuff. So free is better than that. Let's see. So we talked about ingress, egress. We actually already covered a lot of this. But on-premise, we talked about HDFS, min.io is another one, just a pure storage. Ceph we talked about. In terms of formatting of files, right? So people will store data as Parquet or JSON or CSV. Delta Lake is a library from Databricks that allows you to do ACID transactions on top of this Parquet database, Parquet back database. But it's still under the hood, it's still Parquet. So what you can do is you can read from Parquet and then save it to Data Lake. It'll just have other data that has other metadata associated with that Parquet data. Another thing that I think Delta Lake supports is like version changes to the data itself. It stores those versions for you. It's pretty cool. Delta Lake is you don't have to use Databricks with Delta Lake. You can use Delta Lake in Apache Spark running on your own system. But Delta Lake is basically the native kind of data lake interaction engine for Databricks. Some people actually use they use databases for a data lake. And what do I mean by that? Just like S3, right? They'll have a key and they'll have a value, and that value could be anything. So they'll put stuff into Bigtable, or they'll even have Cassandra and they'll just dump stuff in there and read it. And the reason they would do this is if they have their own private implementation, Bigtable replicates that data pretty quickly. I don't know if it's faster than S3, but Bigtable, the data is available elsewhere. And then with Cassandra, same thing, right? You add data in one part of the world and it replicates and is available in the other part of the world. Not commonly, but it's I always ask why are you using this versus using S3 or Google Storage, and the answer is always basically consistency and speed. That they want the data to be in a certain way, in a certain structure, and available at a certain speed. I don't know, S3 is pretty fast. Like you put it within maybe 15 milliseconds, it's available on the other side of the world. And if you really, really are worried about it, you can always write to different buckets that are in different regions at the same time. Any thoughts on this? Has anybody seen this, like a data lake, using like a big scale database for a data lake? Okay. We talked about all this stuff earlier. So I don't know if there's any other cloud providers that matter, but basically Amazon, Azure, and Google are the only ones that like matter. They're being used enough where if you went with one of these, you're not going to be shit out of luck for the talent around it, or essentially the scale, right? Well, Google went down this morning, so you never know. And then there's Snowflake, which is not quite open. It's not open source, but the thing with Snowflake is that it is now available on Azure and AWS, so it may be a way to mitigate the risk. So like if all of a sudden you're unhappy with Amazon, you could move over to Azure. Personally, I think if you can help it, store data in a non-proprietary format like Parquet, store it on a file system, and it doesn't matter where you move that data, you can always use it using your whatever programming language you want to use. So, even if you don't use a open source object storage, right, you're using a cloud object storage, if you stick with these formats, you're probably okay. Maybe even XML. There's a bunch of resources that we'll put up on the blog. Just different reasons, and also what's interesting is how different clouds will define their data lake in their way. So, for example, if you look at Amazon's definition of what a data lake is, they'll kind of talk about it. They'll talk about it, and then at the end of the day, they'll say, "Oh yeah, use S3." Right? They actually have a talk about Data Swamp as well. So this is Amazon's explanation of it, or visual explanation of a data lake. Whereas if you look for Google Cloud Data Lake, theirs is slightly different. But I would say they're pretty similar. Let's see what they say here. Let's see, what do they say for storage, right? So they just suggest storing it in Google Cloud Storage. And then you can do stuff like, where did it talk about BigQuery? Right, so in Amazon's ecosystem, you have access to Amazon EMR, you have access to via Databricks or Athena. On Google, you'll have access to BigQuery or their version of Hadoop, right? This is their version of EMR. Dataflow, I haven't used Dataflow, but Dataflow is pretty interesting. You can even write Dataflow jobs, I think in Spark or Flink, last time I checked, which are open source. Trying to think. Oh yeah, no. Nowadays they're basically sticking with the Beam SDK, which Apache Beam can run on Spark and on Flink. So cool stuff. And then finally, Azure Data Analytics. Let's see, where to go. Data Lake, we call it Azure Data Lake Analytics. So this is kind of their version of Snowflake, but they call it USQL. And USQL, basically like, no, this is a video. I don't want to see the video. There's like what does USQL look like? But all Azure Data Lake Analytics is you store data on Azure Data Lake Storage, right? And then you have this serverless query engine to basically get access to that data. Obi, did you want to add anything? You're talking about data lakes tomorrow.
Yeah, I think we actually covered most of it. We talked about data swamps and how that's mostly up to your organization and your process. Yeah, Azure Data Lake Analytics also includes their own like Spark Analytics as well as USQL.
Oh, really? Cool. Very cool. Let's see. Somebody's asking for a link for tomorrow's talk.
Where is that Eventbrite link?
Let's see.
Well, regardless, it'll be on the Anant Corp YouTube channel, streamed there tomorrow morning.
We'll get you a link, Mary. Let's see.
As soon as I can find it.
Any other thoughts or comments about data lakes today, guys? Oh, great. Well, if there aren't any other comments, let's quickly take a look at the backlog of ideas for next week's topic. So what are data lakes was on the backlog, and it was in line with one of these. So we covered it. Any thoughts, ideas for next week? Or are there any volunteers to talk about a topic next week? Let's see. All right. Well, if not, I will think of something from the backlog or from the data engineering path, and we'll go from there. So next week, same time, same place, we're going to have Data Engineers Lunch at noon Eastern, 11 Central. Don't forget to subscribe to the YouTube. There's a YouTube playlist for Data Engineering Lunch. And you can always find us at Data Wranglers DC. And I'll put that link in chat as well. And if you're curious about other data-related events, like the one that Will is going to be speaking at next week, we have Data Community DC. And let's see. Mike, do you have any things coming up?
Not yet, but January, February, we're going to have some free workshops in R.
This is statistical seminars?
Yeah. And then after that, Python.
Cool. So statistical seminars, DC is another one of the members of the Data Community DC. Check them out for some workshops coming up. Yeah, you said in January. I don't see them on here, so maybe they're going to just be on a Data Community DC when they get updated, right?
I'll post it. I haven't posted it yet.
Oh, okay.
I'm just getting the materials ready.
Got it. We'll be on the lookout. Cool. Any other announcements for events or upcoming meetups? Well, thanks everybody. Have a wonderful rest of the day and the rest of the week as we gonna come around third base for the year. Stick in there. 2021 is gonna be way better than 2020. That's my belief.
I believe you.
Take care, everybody. See you next week.
See you next
Thank you, Rahul.
Thank you.
Yeah.